our rigid records now, in the end of this year, it's near 5 million. But in 2006, the rigid records total amount is just the 2.5 million. So you can find in the several years, the increase very quickly, and also due to the economy of our country. Another, if you have in Beijing, we have in our institute. I come from the same institute with Professor Chen, but I come from the State Laboratory of boundary layer physics and almost chemistry laboratory. So this is an important platform to measure the vertical depression of air pollutant and also the meteorological condition in Beijing city. This tower is built in 1979. That area in Beijing area is not so large. Now Beijing city area is almost larger than 400 square kilometer. So that is very mega city. But now, at that time, in 1979, our tower is located in the suburb area of Beijing city. Now, that is become the urban area in Beijing. That is to show the location of a tower. You can find around the tower, the traffic is heavy. They also have a expressway. Now, this to the Badali, if you go to the Great Wall, that is the important highway from Beijing city to the Great Wall. Now we have changed this express name with the Badali Express Highway to Beijing to Tibetan Express Highway. This is the location. From the Google Earth, we can find this is the location of our tower. Now you can find in the northwest, that is the National Olympic Park. That is the built, finished in 2008. That is for the 2008 Olympic Games. So in this area, they have a larger park. Then we can also, in this direction, if you wind from this direction, we can find this carbon dioxide, the flux is small. And during the summertime, they have a negative. That you say they can absorb some carbon dioxide. Usually, for the land surface, just is the source of carbon dioxide. It's not the sink of carbon dioxide. However, we use the method we have to use this eddy coherence. For the persistent step, first we have to do the spike detection and the rejection, and also to do coordinate rotation and the planetary fit. Planetary fit is discouraged when do the strong wind, maybe the ball has some vibration. So we want to evaluate the vertical speed due to the vibration of the ball. So for the calculate each sample which has a half-hour flux because from 1990s for the microbiology, we can use the EC method to measure the surface energy budget. We can found that the available energy, that is the net radiation minus the soil heat flux. If in the high canopy, we need also minus this heat storage in the canopy layer. But they need to balance by the sensible and the water vapor or the latent heat flux. But usually we can find available energy is larger than sensible heat flux and the latent heat flux. So what's the energy median? One is due to the low frequency. That is say we need to calculate this half hour to 1 hour or 2 hours. However, because due to the solar radiation during the daytime, we know this boundary layer have a very distinctive diurnal cycle. So if you calculate this flux more than 1 hour, you need to elevate the diurnal cycle, the diurnal variation due to the solar radiation because they will increase. And elevate maximum in the north, then we can decrease. So that's why we still select the half-hour flux as a sample. And also, due to this density variation, we need to do the double peer correlation to the original flux. And also, we need to do the quality control. As we say, because we know most of the boundary layer theory, we just use the heterogeneous surface. However, when we to analyze how to interpret our results, first we need to do the quality control. Just you say, we should to get the quality flux. First, we need we have a measure is at the steady state. Like you say, on the unsteady, maybe this turbulence is not so developed. So what we have measured by the EC, the flux is not correct. Another we can to other category category to check our data quality. Then I will show some results we have obtained in the 4 years from 2006 to 2009. I would say we have to analyze this flood. We have to get over the 47 meters high above the surface in our tower. From 80, our tower is, I would show is 325 meters high. From the bottom, 80 meters high to the top of this tower, we have 15 layers to measure the wind speed, the temperature, humidity. And also we have set up 3-layer EC system, anti-coherent, to measure this carbon and also water vapor flux at the 47 meters high and 140 meters high. And the other the last layer is we have set up 280 meters high. In this report, I just show what we have to get it over the last to the lower layer. How to compare the floods we have obtained over the 3 layers. This is the work we are still doing, as also we want to do. First, I will show how about this meteorological condition during the 4 year. In Beijing, from 1980, we can calculate calamity orange the precipitation is less than 300 millimeter for the annual precipitation. And 2006 and 2004 is less than 500 millimeter. But the 2008 and 2009 was over 600 millimeter. So that is we have some transition because especially from 1990s in Beijing every year, the precipitation is decreased. That's decreased the trend is very, very tentative. But from this century, we can find the annual precipitation has some record increase. And also because Beijing is located in the same humidity area, so you can find they have a very distinctive seasonal cycle about the precipitation. So each year for the rain season, it starts from May to the end of September or the beginning of October. And you can find they have a strong and also have a large annual variability. And different year, this distribution of the precipitation is also totally different. That you say, I also want to change how about this meteorological factor effect on the carbon dioxide flux over the urban area. Then we have to show the wind rows because we can find that is for the 4 years wind rows. We can find the prevailing wind was northwest and southeast wind. That's during the winter time is northwest. During the summertime is southeast. From this wind speed, we can find the southwest sector of this experiencing the low wind speed due to the tall building in this direction. Because that's why we use the wind rows. Then I will also the carbon dioxide flux in the urban area also have a relationship with the wind because during the different wind section, this building, the roughness elements is different. So that's so when we to estimate the carbon dioxide flux, we need to know this roughness elements distribution around your magic tower. So firstly, we want to say because before we want to analyze your floods, first we need to know what is the flood we have gathered from our tower. We want to get the 40% model. First, you know they have a relationship with the atmospheric stability and also with the measured height, whichever you have to measure. From the atmospheric stability calculated by the time of day, we can find the upper boundary layer, the difference with the lower boundary layer is, especially during the night, this boundary layer is not always stable, and also for the very stable condition is certainly occurred due to the asymptotic heat emission in the urban area, and also another is the release of the stored edge in the canopy and the canopy layer of the urban boundary layer. They have when we release during the night time, so you can find this very stable frequency is not so high. And also we can some transition period. That's transition period. That is always that is centered on the sunrise to the sunset. So during that period, usually this atmospheric stability is natural or weak stable or weak unstable. Then we can to show the footprint analysis. That's why, because if this land surface is homogeneous, so that is what is the product we measured is not important. But in the urban area, because the land surface is heterogeneous, so you need to know which you have to measure by your sensor over this over your tower area. You can find 90% of this flux come from this is a radius of 2 kilometers around our tower from this cycle. This is show the convergent footprint during the whole of the year because, as we know, in the unstable, this area will be small. For the stable, will be large. This is the convergent footprint analysis in this area. So the percentage of vegetation within the radius of 2 kilometers around the tower and derived from the satellite photograph red color filter technology is appreciated for the 15%. And we know because in the city area, especially to study about the energy budgeting, it's difficult. If you send where you can set up your radio meter, because if you set up the roof of the building, you can find that the material is concentrated. So maybe this albedo is large, it's near 0.3. If you set over the grassland, it's just 0.1, 0.5. So we need to use the model to get the energy budget, especially for the one wave and upward solar variation. That's why we need to use this satellite data to get how about the difference land use fraction over this area. Until now, unfortunately, because it's difficult to distinguish the roof of the building and with the paved road. In the next step, we want to use the high imaging from this airplane. Maybe that's due to some problem. Until now, we didn't get it from our government. We will try to find in the next step. Or how to say, because I just show this is about this aerodynamic reference and the zero plane display height over our tower. Why we show this? We can to say from the roughness lines during the 4 sector because we have just to decrease to 4 sector. You can almost is larger than 3 meters. So that is a big. This area is located in the typical urban area. So. And also, we can from this zero plane display height, we can see we have set up our sensor is at 47, just is almost 1.5 times of this zero plane display made. We can to issue our measurement is look on the initial sublayer, that is the constant flux layer. For this vegetation, we can find just from the southeast and also northwest is nearly 20%, especially from this direction. This is have a national Olympic park. So then we also have talk about the effect on the carbon dioxide flux. So as we know, because Dr. Stewart, this paper, they have a new paper just published online this month on the polluting of American Meteorological Society. They have to discourage. Before, we have just for the scientific research, when they set up their measurements, just to clarify this land surface as rural surface, land surface, suburban surface, urban surface. But due to the building, the structure and the distribution of the building, and also due to the land use, land surface cover, so for the urban surface also is totally, sometimes it's totally different. Now, Dr. Stewart and T.R. Oko, and Oko Professor Oko, they have classified the local climate zone in the urban area with at least more than 10 categories. So according to their local climate zone, clarification in the urban area. We can find in the northwest in Beijing. This is